Cybersecurity concerns are ever evolving. OT cybersecurity is even more complex, and it's so much more than just software and hardware. How do you stay on top of it all? Aaron Crow has over 25 years experience with cybersecurity. 15 of those years focused on operational technology across multiple industries, and he wants to help you. Welcome to the Protect OT Cybersecurity Podcast, brought to you by Industrial Defender. Now here's your host, Aaron Crow.
Awesome. Hey, John, thank you so much for joining me today. Why don't you take a second, introduce yourself, who you are, who do you work for, what do you guys do, just kind of the whole spiel. That way everybody that may or may not know you can get to know you really quickly.
Yeah, sure. Thanks, Aaron. And thanks for having me on the podcast. John Cusimano. My background is, for my whole career coming out of college, has been in industrial automation and controls. My very first job coming out of college was for Eastman Chemical. So I ended up in a chemical division, but I was doing control systems, PLCs, DCS, automation. And then I stayed with that for really almost 20 years, process control, and I kind of specialized in safety. So safety instrumented systems for many years was a specialty, and I worked for a couple manufacturers of those types of products. So I was more of a product marketing, product management person for many years, but always in industrial automation. And then, about 15 years ago now, I had an opportunity to move from product into consulting. One of my former bosses had started a company and specializing in safety system consulting, and he said, "Wow, I think we should pay attention to this cybersecurity stuff. I think it's going to be a thing." And we were very good at doing failure and risk analysis of random failures or component fails or a software bug, but the whole deliberate side of using cyber to deliberately tamper with a PLC or a DCS or a network was largely it was just being kind of researched at that time.
Right.
So I moved into the field and really never looked back. And so I've been in ICS, OT, SCADA, whatever you want to call it, security now for 15 years. And in this case, it's always been on the engineering consulting services, professional services side.
Sure. Yeah, and it's ironic, right? So we talk about cyber and, risk analysis and looking and understanding, all of the things from a cyber perspective. But to your point, like, we've been doing this in the SCADA, ICS, in this space forever. It just wasn't necessarily cyber focused, right? It was what's the risk of this component breaking down, or the wiring, or the programming, but it was never from a bad actor from the outside coming in. It was, Bob misconfigured something. What happens if when I walk out and I touch this thing and it stops working? How do I get it back up? Build redundancies, like all of that type of stuff. We did that on a daily basis. We just had to start factoring in the cyber component and the third party nation states and APTs and all these other things as additional surface attack environments for these spaces, right?
Right, and even making sure that in the event of a failure, that the system failed in the safest manner that it could.
Right.
And so same thing applies with cybersecurity. You still want to make sure that if the system is tampered with, hopefully that the attacker can't also change the failure mode. Though
right.
There's Triton kind of proved that it's possible, but that's pretty difficult to change the way the system's going to fail in the face of tampering. But you can also use the system. I think the thing that's scariest about somebody tampering with the actual logic controllers is that they can use the system as it's designed, used it against itself. You just send a very valid command to open a valve or stop a pump, and bad things can happen.
Yeah, and digitizing that stuff, 20, 30 years ago, opening that valve, I'd have to have physical access. I'd have to send somebody out and physically move a valve, right? And as we started making that more automated, and then we connected it and interconnected it on networks, and we digitized it. We made that. I can do that from the control room or from remote, from corporate, or from anywhere in the world. And that risk has been exponentially increased because I can do it from anywhere.
The attack surface is so much bigger.
Yeah. If I can do it from my office, I can do it from China, right?
Mm-hmm. Yep.
In theory. So what are the alignments on, looking at risk? When you're doing, you're looking at risk, analysis of an environment, obviously from a cyber perspective, but the physical component, especially in OT, it's different than doing a risk assessment in IT, because the impacts are different and the responses are different, and failing open, like you wouldn't probably fail open in an IT world, but you have to in an OT world because of safety, because of equipment failure, because of all of those other factors that aren't necessarily components in an IT assessment, right?
Mm-hmm. No, that's right. Yeah. So you really, when you're doing it, the big difference between doing a cyber risk assessment in IT and in OT is that you have to be focused on the consequences, to the operational consequences. What is, we always tell people when we're going through these, because it's usually kind of a workshop format, is you want to look at what's the worst case credible consequence if somebody else was in control of your systems.
Sure.
And that's a pretty scary thought. But what if somebody else, you've got operators that are sitting in front of their consoles, but like in the case that was pretty well documented in Ukraine, right? Somebody else was driving the screen, and all the operators could do was take pictures of it because they had no ability to control it.
Right.
Yeah.
And
so,
that's what operators are trained for, right? We train them to, if they can't control it, to control it, right? Meaning if they can't do normal operations, how do they trip out the unit, get it to a safe place? Again, because there's physical issues. Being in power utility, I've been in a couple of those scenarios. It had nothing to do with an attack. It had to do with misconfiguration or whatever the reason.
Yeah.
But the outcome is still the same. The outcome is
right.
I had to shut the unit down.
Right. So you got to run over and hit an e-stop. Right.
Exactly. Right. They hit that emergency button because I didn't have control. They couldn't see what they need to do. And of course the PLCs were doing their normal thing and they were running fine.
They're gonna.
But me as a human, I couldn't control it. So they had to.
You're blind. Yeah.
Yeah.
Nobody wants to be running blind. Yeah, so that's so doing a risk assessment in OT is different from that perspective, is that you really have to understand the consequences, and you have to understand how the system actually works. What is normal operation, what is abnormal, and understanding what is fail safe is important too, and making sure that you, as much as you can, you drive the system to, if it's going to fail, please fail safely.
Yeah, and that what is normal, right? That's a big ask now, because so you have a background coming from the engineering side, and a lot of your career until you transitioned over to the cyber side, it was really on the automation and the control logic and all of the engineering side of the house, and that's what most of our systems engineers that are at these locations, that's their specialty. That's what they have experience in. That's what their degree is. That's what they were trained on, right? But as we started bringing these commercially off-the-shelf IT products, switches and firewalls and servers and all these other things in, that's not their expertise. And unfortunately, there is no person that is sitting next to them that has that expertise. So they understand part of the equation, but they don't necessarily understand the other. So when you say, what does normal look like? They know normal from the engineering side, but they don't necessarily understand what normal operations on the network side, on the cyber side looks like. And that's where there's a huge gap, in my opinion, in the OT side that we still haven't filled the void with the understanding of what's going on in these spaces.
Yeah. And that's where I found, switching gears just a little bit, there are standards that can help with that. And I've been involved in the 62443 standard for coming up on 15 years now, pretty much. Right. And as both a way to learn, I got involved in the committees early in my ICS security journey, and have continued to stay involved. And one of the things that I worked on for 7 years actually was the what's called the 3-2 part of the standard. It's titled Security Risk for Design, and it was put together by a team of both asset owners from oil and gas and chemical companies, as well as people, other consultants and other vendors and so on, work together to put together the standard. And the standard talks about how to go through this process to actually really understand and quantify as best you can the risk. And one of the core elements or kind of tenets of that is that, like you said, no one person has those answers. Sure. You have to. The ideal way to do this is in a workshop setting, so that you bring together say you're studying doing a risk assessment on. We'll stay with the kind of like the pipeline theme. So you're looking at a pump station and or a terminal, and you got some storage tanks there, and you've got some big pumps and rotating equipment and so on. You work with the automation engineers that are responsible for that site. You bring in whoever's responsible for IT security at the site. That might be corporate. There could be somebody local. You can definitely consult with health and safety to make sure you understand what are the kind of the worst case consequences of overflowing a tank, for example, and what are some of the safeguards that are already in place, such as dikes and things like that, rupture discs and so on. And you work through those scenarios, and it doesn't take days. It could take, you want to spend a concerted amount of time doing that, but spending some time talking through what are the credible scenarios, and what safeguards do we have in place and controls, and where do we have gaps? And really, ideally, what you're trying to do is identify, okay, what are the gaps that we need to address where we have unacceptably high risk.
Yeah, I mean, ultimately, it's a template, because at the end of the day, most people were starting out. We're like, I don't even know where to begin. Like, I don't know what I don't know. How do I start? Where do I begin? And it is okay, start here. What about this? Do you have the right people at the table? And helping you ask those questions to put it in a box instead of it. How do you eat an elephant one bite at a time? Right? It's that there's work that has to be done, but you got to make sure that you have the right parties involved and you're asking the right questions. And how do you know you're asking the right questions unless you're using some kind of framework that helps you walk that path?
Right. And that's what the ISA did in that standard, and the 62443 standard is. In fact, that particular document has a really nice, simple work flowchart in the beginning that basically says this is the methodology, and it's not rocket science. But like you said, it's a starting point. It's a methodology and a structured way to approach the problem.
What are some of the more difficult or struggles that you've seen in customers adopting and starting out, right? From nothing to opening 62443 and walking through that exercise and knowing how to answer those questions or what to do right?
Yeah, because it's really overwhelming, especially if for companies that really haven't put any kind of formal process in place. It's where do I start? And it's overwhelming. And if even, as much as I like the 62443 standards, it's a mountain. If you printed them all out, somebody said it's like a foot of paper. So that's overwhelming as well. So there's been a lot of good guidance written out there about having a good framework and getting down to kind of like your top 10 controls that you should be looking at. Years ago, I wrote a white paper with Eric Byers called the 7 steps to ICS security. Some of those fundamentals, they haven't changed over the last 15 years. So you certainly want to focus on the fundamentals, right? But one of those is really understanding your risk environment, because you don't want to paint everything with the same brush.
Sure.
You can, but it's probably you're going to be in many cases you're overdoing it.
Yeah.
And you want to focus on those things that are going to move the needle the most on risk. So part of your 7-step or 6-step or 10-step process, whatever one you want to adopt, there's a bunch out there. It should involve really understanding the risk to your facilities and tailoring your program to match that.
Yeah, one of the stories I always like telling when I'm going through something, like I can have 2 PLCs. They could be the exact same make, model, same firmware, everything. One's controlling the ice machine and one's controlling a turbine. They have the same risk, CVE score, the risk, all
same
that
vulnerability
is
profile is the same. Yeah.
But the risk to the business is not the same.
Because the consequence changed. Yeah.
Exactly, right? The ice machine being down is an inconvenience. The turbine being down is a detriment to my business and my organization and my all of that.
Could be
right?
equipment damage and everything else, right? Yeah.
Human life and safety. There's all sorts of things that goes into that, right? Now, obviously, the ice machine could be safety from, you could paint the story, but still, the point is to have that level of conversation, right? It's not enough to just know my PLC has this vulnerability. I have to know, so what? What is that thing, and what is it doing, and how does that impact my business? And those are the types of questions. That's the point of tabletop exercises. That's the point of going through these standards and going line by line by line. The other piece that I've seen a lot of is I'm building a program, right? I choose a framework. I choose my controls. And entry level people start thinking, hey, I have to be, if it's a 1 to 5, like, any number of standards, right? But let's say that I think I have to be mature in everything, right? I have to be a 5 on everything. Like, you're not going to be a 5. You're not going to be the best. It's not gold plating. It's not platinum coating, right? It is what is reasonable. Like, you're not going to patch every day in OT. So don't pretend that you are. Like, don't make that your standard. Don't make that the baseline of where you're at. If it's once a year, say once a year. Like, it's better to be accurate about what you're going to do so that you can put other mitigations around it instead of saying, hey, we're going to patch every day, when you don't have the people, the process, the technology, or any of the things that you need to do that.
Yeah, the most important thing that I found around that patching is being able to identify which of the vulnerabilities that I know I have, which ones do I must I address immediately, versus which ones can wait. And so having tools, that's the other important thing with any if you're going to start off on a program, you need to have good information.
Sure.
Even if you're going to do a risk assessment, you have to have good information, because you have to understand, how is the system architected? How are the networks architected? What assets do I have? So all those, again, those fundamentals of like asset inventory and network architecture diagrams, you have to have that information. There's the old saying, you can't protect what you don't know you have.
Right.
So that's really, and that's a lot of the value that a lot of the technology has brought to us in the last few years, is that ability to pretty quickly get a good picture of current state. This is my current state. This is what my network looks like. These are my assets. These are all the vulnerabilities that the tools help me discover. Now you got to answer that last very important question, which is, so what?
The most important question of all, right?
Yeah.
Because to your point, like, there's a lot of great tools. There's a lot of great tools that do a lot of different things, from vulnerability detection to network mapping, like all of those things. But it's about, what am I going to do with it? Like, what can I do with it? What actions can I can give you a list of 200,000 vulnerabilities in your environment. What do you do with that when you have an OT staff of 1? You can't do anything.
You got to try to find out of those, which are the ones that are really going to hurt me.
Right.
And that's not easy, but there is a method to do that. We call it, from the folks that I've worked with over the years, we call it vulnerability rationalization.
Right.
And it's very similar to the concept of alarm rationalization.
Yep.
In control system, there's been a movement now for probably 20 years, but the idea of, especially as alarms got cheaper. So as we moved from hardwired alarm panels, where you had every alarm was expensive, to putting alarm screens on your HMI, which are basically free, we kind of quickly found ourselves in this condition where we had alarm overload, and the operators were just bombarded with alarms, and they didn't know how to respond. And even events like, going way back, the 3 Mile Island event was basically considered an alarm failure.
Right.
Because there was an alarm, but it was like somewhere like on the back of the console. The operators didn't see it. So the most important alarms weren't being presented to the operator correctly. Right. So that same idea of alarm prioritization and rationalizing alarms, so you only show the operator the ones that they really need to respond to. Applying that same thing to vulnerabilities. Yes, great. I've got tools that can help me discover thousands of vulnerabilities. Now, how do I know which ones I really need to patch? And so there is a method around that, that's based, it's a risk-based method. So first you have to understand the risks to the assets, and then knowing, like you said, which of the PLCs, because I have 2 identical PLCs with identical vulnerabilities, which one do I need to do first?
Right.
Well, you can answer that question, but you have to understand the consequences.
Sure. And that comes back to where you started this. You have to have the right people in the room, right? Because me as a cyber guy, I may not understand the business implication. I see two PLCs with the same vulnerabilities. I don't know which one is more important. I need that business person that says, well, this one does this and this one does that. This one's more important. We should prioritize that one over the other one. Like, you need both sets of that conversation to really understand the risk to your business.
Yeah, because there's variables that a software application can't know about.
Correct.
I mean, I suppose it could if you trained it, I guess. Yeah.
Right. Or you gave it that information.
But most of that information is in people's heads that you need to somehow make it more programmatic, which is, probably the end game is to try to get there. But in the meantime, just go ask the people.
Right. That's the easiest thing, is have a conversation, right?
Yeah.
So what kind of, talk more about that risk quantification, as far as, how do you know which one is the most important? Is it based upon the asset? Is it based upon the vulnerability? It's got to be some combination of a lot of factors, right?
Yep. But the formula is actually pretty simple. If you go back to, textbook risk, basically says that the risk is a function of the likelihood of something bad happening and the severity of that bad thing happening. And that applies to financial risk, health risk, cybersecurity risk.
Sure.
And in security risk, we usually take that likelihood because that's the hardest thing to quantify. Mm-hmm. And we break that down into its kind of sub-elements, which usually has to basically do with how exploitable is it. So what is the threat, and how sophisticated and capable and motivated is the threat?
Sure.
And how vulnerable is the asset? Is it connected to the internet with no controls, or is it buried multiple levels down with lots of barriers? Those are the two main variables. You can break it down even further, but that's how you can estimate the likelihood. And so, following 62443, it basically says, okay, so you're approaching a big system. Say you're like trying to do a risk assessment on the control systems for a refinery. Mm-hmm. You're going to have a massive DCS system. You're going to have SI safety systems. You're going to have PLCs. You can't, eat the elephant in one bite.
Sure.
You have to break it down. So the construct coming out of 62443 is that the idea of zones and conduits. So you start to break it down. So in the case of a refinery, you're first going to break it down into unit operations. I've got a crude unit. I've got a alky unit, and so on. Each of those has a control system, maybe multiple. So you start breaking those down into security zones. And then you can further start to group together like assets and say, okay, so I've got controllers, I've got engineering workstations, I've got operator stations. So I've got different types of assets that have a different risk profile.
Sure.
Because, like you said, PLC here and PLC here could have different consequences.
Right.
But by starting to build out this hierarchy and breaking it down, then you can look zone by zone, group by group, and start to ask those questions. And it actually, you should be surprised how much easier it gets when you're taking, instead of trying to look at this giant picture, to looking at, okay, we're going to look for the next 15 minutes, we're going to talk about what happens if a safety system is compromised.
Right. Just this one system, the small system in the middle.
Yeah. Then you start to answer those questions, and then you form the bigger picture of where the risks are. It's not that complicated once you start to break it down like that.
Yeah, but like you said, right? When you're looking at that whole system overall, it can be overwhelming. Where
it's overwhelming,
do I start? Which is worse. But if you just pick one, okay, I picked this safety system, and then you go to the next system. Is this one more or less than risky to my environment if it shuts down? Okay, it's more. Okay, what does that mean? Did I put that one too high or too low? And then you're adjusting as you're moving along. You're probably moving things around based upon new knowledge that you have.
Yes, you're right.
You're done
right.
At the end.
You start to build out that picture, and you're generally dealing with orders of magnitude anyway, because you're not trying to come up with a precise risk score.
Right.
You're trying to get, is this riskier than this?
Correct. I need to be able to prioritize A or B.
It's relative risk.
Right.
Yeah.
Right. It's not a perfect score. Is this more risky than that? So I know if I got 2 of the same alerts came up, I know, hey, I should go do that one instead of this one. That doesn't mean I don't care about this one. It just means I need to do this one first.
Right. Yep. And once you understand that, then you have a really good model of your system,
right,
of that facility, and you can use that over time to continue. So you might. It's not uncommon for us to work with this. Same client would come back and want to refresh every year or two, because well, we changed this, we put this in, we new vulnerabilities were discovered, new threats actors have emerged. So, but once you've got the base model, it's actually really easy to look at what changed and what's the impact of those changes.
Yeah, because the overall operations of your environment probably didn't change. Like you still have the same components, but I'm adjusting risk based on other data, but I'm not starting from scratch. I'm just adjusting numbers based on little factors that have changed things. So it's an easier exercise the more that you've done it.
Yep. So you're effectively building a model and then just maintaining the model. It's almost like a risk digital twin.
Right. Yeah. I mean, it's a paper exercise, but at the end of the day, that's a good starting point, right? And it goes back to what you said before. It's that foundational thing. Like how could, using that example, like how could you do that unless you had an asset inventory, unless you understood where your assets were, what business function they were serving? Like those are the first steps that you need even before you're able to answer some of these questions. So maybe, do you see sometimes when they're going through this exercise, a lot of that stuff is discovery that your customers or the clients are not knowing? I don't know what that is. Let's go find out.
Yeah. So, practically when doing one of these as a project, it usually starts with, quite a bit of homework.
Right.
Before you even sit down and take, when you start putting people in a room or in a virtual meeting, you don't want to waste their time. These are people, especially operations folks, they're hard to get. So you want to make sure you do all your homework up front.
Right.
For people who are familiar with HAZOPs, PHA safety studies, they'll know they can relate to this, because you wouldn't sit down and do a HAZOP without having good P&ID drawings of how's everything piped and instrumented.
Sure.
You're wasting people's time if you don't come in with good information like that. Same thing applies here. You want to make sure you have good information. You've got up-to-date network architecture diagrams, which very few facilities have those. Up-to-date inventory lists, that's much better now with the technology that we have in place, but still there's gaps. So that homework's really important because, like I said, you don't want to waste people's time.
Yeah. And then,
but if you have to, you can go off and research, say, oh, we just don't know the answer to this, we're going to have to go study.
Well, and that's another example where maybe you start with a system you do know the information for. While you're waiting to get information for a system maybe you don't have that information for.
That's right. Yep.
Yeah. So how do you take that analysis? So you've gone through, you do that 62443 exercise, you're kind of mapping out the risk. How do you turn that into a program to do something about it? What do I do with that thing? Turn it into something, right? An action item after that fact.
Yeah. So there's a couple ways that usually will work out. So coming out of that, you're going to have a punch list of you're hopefully going to have a ranked set of recommendations coming out of there. These are the things that you need to go do first, second, third, and that can be used to build out a roadmap for an organization, because some things, so let's say the thing that's going to reduce the risk the most is re-segmenting your network.
Sure.
That's a big task to do, completely re-segment your network. So as much as you might like to go do that first, that's going to be a longer project. Yeah. So you may start it, but so the other thing you have to look at with these, besides just the risk reduction, is also the cost benefit analysis.
Sure.
And also your budget. How much money do we have to spend here?
Right.
So usually the output of that study is going to feed into a whole road mapping, budgeting exercise to go figure out, okay, what are we going to do in the next 6 months, in the next year, in the next 3 years? Yeah. And then also start to build that into the program, the policies, standards, procedures. Mm-hmm. Yeah, because the learnings of that are going to almost certainly going to cause you to want to update some of your program documents.
Sure. Yeah, I think that's the thing that we miss sometimes is it's not all technology, right? It's people, process, and technology, and all those things together build out the future, right? You can't just implement a product, a technology, no matter how great that technology is, unless you have the people and the processes to run it, to maintain it, to do something with the data when it fires an alert. Like all that stuff, as I'm implementing a tool, it creates alerts, it creates all these things. What do I do with that? Like who's going to assign it? Who's responsible for it? Who's upkeeping it? Who's maintaining it? Who's responding when certain things happen? All of that stuff has to be part of this conversation, other than just, hey, I found this cool tool, let's go implement it, right? That's a good step,
Yeah.
but you got to have the so what. Why am I doing this? What am I doing with it? How am I going to make sure it's productive and all those types of things too?
Yeah. In fact, I can give you an example, a real example from a study did years ago. So one of the highest risk items discovered was that the operator, this was a pipeline application, and the operator had a button on their operator screen where they could put a device into bypass. So say a pressure transmitter fails on the line, and so a legitimate thing you would do would be to bypass that device so that you don't have to shut down. You know somebody's out there replacing the transmitter. You put it into bypass.
Right.
Problem with that is that the operator could either accidentally leave it in bypass, or an attacker could overwrite that, forcing an IO effectively and override that. So the simple solution there was, so this was basically a button on the HMI that the operator could press that would send it was either Modbus or OPC, I think it was OPC, but send basically an unauthenticated OPC command to tell the controller to force that bit. So the simple solution was to be able to put in an additional control so that the operator or the attacker couldn't just send that command. They also had to, I think they went with more like a key switch, something physical, where somebody local would have to say, okay, I'm going to allow these bypass commands to come through.
Right.
And then when they're done, almost like a lockbox,
Right.
I'm going to remove the lock, and now everything's back to normal. But that way you can't accidentally leave things in a mode where anybody at any time could send that command. You're only opening a window, and you're monitoring and controlling that window.
Yeah, it's like a lockout tagout in a plant environment, right?
Yes.
It's a lottery,
Yes.
right?
Yep.
So I'm putting in this position, then I can send those commands, but then I'm going to undo that position, remove my key, so now that bypass can't be there anymore.
Right. Yeah. And before that, there was a procedural way of doing that. When we talked to the operators, they said, "Oh yeah, we always ask the supervisor before we press that button."
Sure.
But that was just procedural.
Right.
And when we said, "Well, what if somebody else pressed that button?" And they said, "Well, that's not possible." They said, "Well, yes, because it's an OPC command. So any other device on this network could send that same command."
Right.
Oh.
Oops. But it also goes back to what we talked about earlier, right? How would they have known that? Like, until you brought that up to them.
No, they wouldn't know that, right?
The only way in their mind it would work is on their operator screen if somebody did that, and nobody in that chair would do that without asking the permission of the supervisor. They just know not to do that. But a bad actor wouldn't care about that.
They're not going to go ask permission, right?
So what are some of the big lessons that you guys have found in going through some basic, walkthroughs of these types of things that people were just the aha moment of, that's a great one right there. But what are some other examples of, basic things that just turned out to be, good findings that they would have never found without going through a simple exercise like this?
Yeah, I can think of at least a couple more off the top of my head. There's been cases, going through these studies or workshops. We always say they're like 80% boredom and 20% or 10% or 20% aha.
Yeah.
Because a lot of it is you're just churning through and you're documenting and you're thinking through, and a lot of it is as you expected.
Yeah.
But there's always those things that are not as expected.
Right.
And so, it's actually seen this more than once, but particularly with ransomware, backups are critical.
Yeah.
And found multiple cases where facility was taking regular backups of the control system, but on a network attached storage device. So so that if that device got compromised, they'd lose their backups. And so that's an obvious one. Another one I can think of is a facility that had legitimate reasons to sometimes pass a file from the enterprise, from the business into the control system network. And so they said, well, we're going to they wanted to get rid of USB sticks. So they replaced it with a secure file transfer mechanism. But in the implementation, some things got kind of overlooked and messed up. And basically there was this file server that if anybody on the business could drop a file into a particular folder, it automatically got sent to the control system. The problem is that anybody could drop any file, and it would replicate it across.
Right. Yeah, that could be a problem.
Yeah. Some stuff with AMS systems. These are systems for smart devices. So smart transmitters, smart field bus enabled, hard enabled. A lot of times those, they're configurable devices. And so you may have this field bus asset management system where the instrument techs can go and they can see all the instruments in one place. And they're great tools. Problem is that they have the ability to talk all the way from wherever that server is, all the way down to the instrument.
Right.
And you can do things like rearrange a transmitter from 4 to 20 equals 0 to 100 pounds PSI to you can reverse it.
Right.
And bad things happen when you do that.
Yeah.
So that's another one where well-intentioned, we put the system in so that we, instrument techs can go here instead of going out to the field and with a handheld. Problem is you got to make sure that you're securing that, and particularly for safety functions that those functions are highly locked down, if writable at all.
Yeah.
It really usually should just be read only.
Yeah, and it's examples like that where, the engineers that put those things in didn't necessarily know the implications of what could happen, and you have to have the right people.
They weren't thinking
asking,
about tampering, right?
Right. Yeah, they weren't thinking.
They're thinking about functionality.
Right.
Yeah.
It needs to work, and this will work, right? And it takes, and it goes back to, and I hear that a lot, and I think it's really important to make sure you have the right people at the table, right? A lot of times I know engineering and operations particularly are hesitant to bring cyber or IT technical network type folks to the table because they don't necessarily understand the business process. But what the value that they do bring is what you just said, right? They're going to ask the questions of how does that work, and thinking about it with a different lens and a different perspective, not trying to tell you how to manage or design your engineering control system, but they'll be able to shed some light on shortcomings in secure file transfer and a lot of these types of things that can cause an operational issue if it's not done correctly, or if you make assumptions that are not accurate and you don't think about it as a risk, you're leaving it wide open because you have a false sense of security in that way.
Yep. I've seen lots of those over the years.
So from all that you've seen and doing assessments and using standards and quantifying risk and operations and doing analysis and turning it into programs, like over the next 5 to 10 years, what are the things that maybe concern you the most that you've seen or you see coming up over the horizon, and maybe what are some of the things that you see as positive that you see that you're excited about coming up over the horizon the next 5 to 10 years?
Yeah, certainly. Our systems, even in the relatively short time that I've been doing this, we've seen so much more complexity in control systems. I have a slide that I use an awful lot that shows the evolution of control systems over the last, say, 40 years, going all the way back to when they were pneumatics and relays, and then basic PLCs with proprietary, if they were networked at all, the proprietary networks, and then moving to Ethernet and SQL databases and Windows operating systems, and now we're even seeing AI and machine learning and all that, and digital transformation, right? So the complexity of these systems has exploded really over the last 30 or so years. And on that same slide, I always show how the facility hasn't changed at all. It's the same pipes and valves and motors and pumps, and you're still making the same chemicals or pushing the same product. But the controls and both the IT and the OT that's underlying and driving this has changed dramatically. Yeah. So the complexity, it's both scary, but also exciting in terms of, all the things you can do with this digital transformation, this technology from a efficiency and optimization standpoint. And AI coming into security also, it's almost a race, right? Is the attacker is going to take more advantage of AI, or the defender is going to take more advantage of AI? Because it can help on both sides.
Sure, 100%. Yeah, and I see that as well, right? Is what can we do? What can we use AI and ML to do to help us? Versus also looking for, hey, bad guys are looking at the same tools that we are. They know what we have. They know we have older systems in OT. They know that these plants have been around for 40 years and haven't physically changed. And the controls have gotten more and more complex, and we don't necessarily have a handle on it. Like, all of these things are known. These are not secrets. We're not saying anything top secret that nobody knows. Like, everybody knows this problem. So we have to somehow stay ahead of this. And, it really goes back to all the way back to just doing and understanding where you are so you can quantify your risk, so you can then decide what you're going to do with it. Build a program, understand, am I lacking technology, people, process? How do I get all those things together? How do I, start doing, before I would ever start talking about AI or any of that, I need to have an understanding of what my assets are. I need to understand where my risk is, right? I can't teach an AI ML model to help me quantify risk in my environment until I know what assets I have. Like, it's super basic.
Yep. Right. Yeah. So that is part of it. The part and the value of building these models is having that kind of baseline. So as things change, you update the model.
Sure.
But because it would make it a little easier to keep up with all the change. Because this is not a boring field, and it's not going to be for the next foreseeable future, right?
Yeah, it's getting more and more intense and more. Job security is good to be here, right? It's a good place to be, and it's so far we've been doing a good job as a community of staying ahead of the 8 ball, but we've got to continue to push forward to maintain.
You're not because you're not going to stop the technology train, right? It's there's so many advantages of technology that you're not going to stop it, because there are some that call for that. They say, well, we should just go back to get rid of all the Windows machines in our facilities. Maybe in some cases that might be the right thing to do, but for the most part, that's not even practical to talk about.
No, it's not. My dad worked in power utility for 40 something years, and if I go back to how he used to run a plant, back in the 70s. I mean, the amount of people it took
panel
to do
boards,
this,
yeah.
Oh, I mean, it was manual. It was tons and tons of people and labor and resources and things like that. It was a completely different environment. And if you were going to remove all of the technology efficiencies that we've got, you would have to have 10x the amount of people to do the same amount of work.
Right. Yep. Yeah. So you're not going to be able to roll back the technology. It is what it is. So you're going to have to learn how to live with it.
Yeah. And do it in a safe way and a smart way, and
right.
Understand your risk. That again, I keep harping on it, but that's the key. Is the goal is not to eliminate risk. The goal is to understand risk and know which risk to focus on. Right? You're never going to get to zero risk. You're never going to get to unhackable. Like, that's not the goal.
No, the goal is to manage it. Yep.
Correct. And to stay ahead of it, understand where your risks are, because you're going to have issues, but you go in with an open eye instead of just assuming, I don't want to look at that. I just assume I'm good, right? That's not
right.
The place to be.
Yeah, and the other approach that a lot of people take is just piling on every security control out there,
right.
And that's also not tenable either long term.
No, it's the exact opposite, right? I'm going to get every tool in the world and throw them at it, and then I've got tools that nobody knows how to use. What am I doing with them? What's the purpose of them? And what value am I getting from them?
Sometimes it's actually counterproductive to security because every tool you put in has access.
Correct. So access and alerts and somebody's got to do something with it. I've got to have human action. I've yet to see anybody that's taking it to the extreme of automation and doing, response, automating everything from detection of an event to automating response in OT. So shutting down a valve automatically without human intervention. Like, we're not there yet. Like, will we get there eventually? Maybe. In the next 10 years? I don't think so. Maybe in very small environments, but large scale critical infrastructure, I don't see it.
Yeah.
So I know you got some things coming up. This is going to drop on November 3rd. So I think you're going to be at a conference. Why don't you tell us where people can find you and how can they get a hold of you?
So next event that I'm going to be attending, speaking at, is the API Cybersecurity Conference. It's in Houston, or technically the Woodlands.
Yeah.
It's November 7th and 8th. So I think I speak on Wednesday.
Very cool. What are you speaking about?
I am speaking about OT cybersecurity programs and taking a fresh look at your programs. Basically, largely a lot of what we talked about today, particularly around taking a risk-based approach to your programs.
Very cool. Yeah. Sounds like a good one. People should definitely jump in, go check out John and listen to his talk and tell him that you heard about him on the podcast. Thank you, John. Anything else, sir?
No, thanks, Aaron. I enjoyed it.
Yeah, absolutely. Thank you for your time, sir. I look forward to hearing your talk.
Okay.
Thanks for listening to the Protect OT Cybersecurity Podcast. If you got some valuable information from today's show, please subscribe, rate, and review the show on Apple Podcasts, Spotify, or wherever you get your podcasts. To learn more about Aaron and to get your free copy of the OT Cybersecurity Solution Buyer's Guide, go to industrialdefender.com. That's industrialdefender.com, or you can click the link in the show notes.